Hello guys, hope you all are doing well. So in the continuation of the previous GATE series, we are solving the questions of GATE 1997. We have completed the section A. So today we will see some of the question of section B. Then in the 2 or 3 video, I will complete 1997. So very first question is, uh, in the given figure below, calculate the power required by the pump to deliver water at 3 meter per second from a pond. The inner diameter is 25 meter. Sorry, inner diameter is 25 mm. That is same for the input and the output. Neglect all the losses, and this height is given in the question is 3 meter. Okay, so straightforward, we will apply P1 by rho g. Suppose if this is 0.1 and this is 0.2 plus V1 square by 2g plus Z1 plus efficiency into pump head is equal to P2 by rho g plus V2 square by 2g plus Z2 plus HF. All the losses are 0, this will 0. Okay. Since the diameter of the inlet and the outlet is same, so velocity will be same at both the points. This will be 0 because atmospheric pressure is applying, because the pond, we are taking the water from the pond and pond is always open. And overhead tank is also we will consider open because it is not given in the question. Okay. Now what else is remaining? Efficiency we will consider 1 because in question there is no efficiency is given. Okay, so pump head will be is equal to Z2 minus Z1, that is equal to 3 meter. Okay, now power required to deliver the fluid rho G Q HF. Density is 1000. For simplicity, G is 10. Q is equal to pi d square by 4 into velocity, pi by 4 into 0.025 square into velocity is 3. It is around 0.0015 meter cube per second. So 0.0015 meter cube per second into 3 is the pump head. Okay, so 10 to the power 4 into 3, it will give value 44.2 watt kg per second meter cube into meter per second square meter cube per second into meter meter. So kg meter per, that is Newton meter cube meter, Newton meter per second. Newton meter is joule, joule per second. Joule per second is watt. Okay, so 44.2 watt. Okay. An equimolar mixture of benzene and toluene is contained in a piston cylinder arrangement at temperature T. What is the maximum pressure below which this mixture will exist as a vapor phase? Okay, so we have mole fraction of vapor phase, that is equimolar mixture. So Y1 is equal to Y2 is equal to 0.5, but we don't have composition of liquid phase X1 and X2. Okay, so X1 plus X2 is equal to 1, X1 is equal to 1 minus X2, X1 is equal to 1 minus X2. Okay, the vapor pressure of benzene and toluene is this. Okay, let X1 composition of benzene, you can take X1 the composition of any of benzene or toluene. Okay, benzene. So applying Rolle's law. What is Rolle's law? Y1 Pt is equal to X1 P1 set, Y2 Pt is equal to X2 P2 set. Add both, you will get Y1 plus Y2 will become 1. So Pt is equal to X1 P1 set plus X2 P2 set. Now PT is equal to, you have to find out the total pressure. X1 is X1, P1 set is 1530 plus 1 minus X1 into 640. So you will get 1530 X1 minus 640 plus minus 640 X1. So 890. So the 890 X1 minus 640. Okay. Now put this value pressure in any one of two. P1, Y1 PT is equal to X1 P1 set. So Y1 is 0.5. PT we have to find out. So you'll put value of X1. So X1 is PT plus 640 upon 890. Okay. So PT plus 640 divided by 890 into 1530, right? So 890, 445, I think. 890 divided by 2, 445. 445 PT is equal to PT plus 640 into 1. Oh, sorry. I did what I did. Sorry. I can do like this. PT 1530 divided by 890. 1 point. Yeah, both are same. 1.72 PT plus into 640 on 100. Oh, this will become plus. This will be minus. So it will be minus here, not plus. So minus 1100 is equal to 1.22 PT. PT is equal to divided by 1.22. Around 901.8 mmHg. Okay. So it is straightforward question, just calculation mistake and sign mistake was there. So it is straightforward. Okay, just read the statement and you can just apply formula and all. Okay. So going to the next question. So find lambda such that the equation has a non-zero solution. So very first we can write this equation like this. Then we'll write this, just replacing d with m. Then the root will be this plus minus this. Okay. We know that for this kind of root, comparing this, alpha is 0, beta is lambda. For this kind of solution, we have, for this kind of roots, we have this kind of solution. Okay. But alpha is 0, so you'll get ultimate solution like this. Now, applying boundary conditions at y equal to 0, x equal to 0. So you'll get ultimately a equal to 0. At y dash is x equal to 1, y dash is equal to 0. You'll get ultimately b cos lambda equal to 0. For a non-zero solution, b will not be equal to 0. That's obvious. Okay. So cos lambda equal to 0. So lambda is equal to 2n plus 1 pi by 2. That is the solution. Okay. So straightforward question, that is simple mathematics and all. And for mathematics, I'll tell you, for mathematics, Ace Academy, just check the spelling. Ace Academy book is very important. Ace Academy book is very important. Okay. I will upload a pic just with this question, the cover page of that book, because it contains all the maths question which GATE had asked from all the branches. That book is very good. I gone through that book around 5 times when I was preparing for my third attempt, I think. And at that time I was I know the solution, I know the answer, like it is just on my fingertip. By seeing the question I can tell the answer. So that book is very very important. If you will go through that book 5 to 6 times, maths will be 15 out of 15 you will do. Okay, this question is little bit important but very lengthy, and I don't think so this kind of question will come, but the concept will come. But question is very very long, and it took almost around 1 hour for me to come to calculate this question, to solve this question, sorry. Okay, so you'll see the question. A feed 1298 Kelvin consists of a gas CO2, O2, N2 and air is passed through a bed of pure carbon. So there is a gas which contains CO2, O2 and N2, and air is also. Air from the external source we are supplying, pure bed of carbon. Two reaction occurs, both goes to completion. That means complete conversion is takes place of what? Carbon and oxygen. Okay, so these two things, carbon and oxygen, will not be in the product because these are complete. Okay, for consuming total carbon we have passed the oxygen, okay, which is completely consumed. So we have only CO2, N2 and OCO at the product. Okay, the combustor is adiabatic, so Q is equal to 0, and the product gas exit 1298 Kelvin. Now see, the feed is 1298 Kelvin and product is 1298 Kelvin. If we will apply NCP delta T, then it will become 0 if we will take feed and product temperature. But this del T is never T feed minus T product. It is T minus T reference. Always remember, I have told you in the very first class when we are solving the questions, this is T minus T reference. Okay. So calculate required moles of CO2 per mole of O2 in feed stream so that the net heat generation is 0 and bed temperature remains 1298 Kelvin. Okay, this is the data given to us. Okay, so we'll solve. So very first thing, C. Let moles of CO2 be A and moles of O2 be B. So moles of CO2 upon moles of O2 will be A by B. That is, let X. These two are the reaction. We have Q is equal to, I told you where to apply this formula when we have heat energy balance with stoichiometric coefficient. We have to apply this formula. For adiabatic system, this whole thing will be equal to 0. So we will take this complete formula. Now reaction goes to completion, so product has only CO2, N2 and CO. Okay. So for this we need to calculate the moles. Total carbon reacted A plus 2B. How? In this, from this reaction, carbon 1 by 1 into A, because moles of CO2 is stoichiometric coefficient of carbon, stoichiometric coefficient of CO2, moles of CO2. So A plus. Second reaction, 2 by 1 into B, stoichiometric coefficient of carbon, stoichiometric coefficient of oxygen into moles of oxygen, B. So A plus 2B. CO formed totally from the reaction it is saying 2A, 2B. CO2 reacted. CO2 reacted from this equation only 1 by 1 into, sorry, 1 by 2 into 1 by 2 into A, 1 by 2 into A. So A by 2. CO2 fed, that is A. So CO2 unreacted, A by 2. Now we have everything. So since the amount of N2 is not given because the amount of air is not given, and since if the amount of air is not given, so we cannot calculate amount of N2. So we'll keep as it is. So very first thing, NCP delta T of CO2, that is product. NCP delta of N2, NCP delta of CO2. CO, sorry. So moles into Cp into 1298 minus T reference is 298 Kelvin. Always in all the question. Always in all the question. Always in all the question. Okay, so we'll give this. So for N2, we'll keep like as it is, and this is for CO. Okay, moles into Cp into del T. So we'll get ultimately this. If we will find for reactant, NCP delta of CO2, N2, O2 and carbon. So CO2, N2 will be remain like this. Even this 1000 will be del T. Okay. Oxygen and carbon. Okay, we'll get ultimately this. Now, delta H of reaction. Now, this is important since we have two reactions. See, we have two reactions. This, okay, and see, we have these two reactions. Okay, from one reaction, delta H of reaction is 170 kilojoule, that is endothermic, and this is minus 220, that is exothermic. So, total heat released will be sum of this. Total heat will be 170 kilojoule per mole of CO2 reacted plus 220 kilojoule per mole O2 reacted. Now, see, we have to cut CO2 reacted, so we have to multiply with the moles of the CO2. So, moles of the CO2 is A and moles of the O2 is B. So, 170 A minus 220 minus 220B. Sorry, it is not 200, it is 220. So 170 Bx minus 220B. Put value here. Okay, when you will put value here and solve, you will get ultimately 230B 230B is equal to 15A plus 170Bx. Okay, now 230B minus 170Bx is equal to 15A. Okay, take B common and divide by here. So 230 minus 170 x is equal to 15 x. A by B is x. Okay, so 230 divided by 185 is equal to x. So x, the ratio of A by B, moles of CO2 to O2 will be 1.243. Okay, so this is a little bit tricky question. Okay, if you will not understand the question, if you will not read the question carefully, you will surely make a mistake. So if you have any kind of doubt, anything, just comment it below. I'll try to reply as soon as possible. Okay, if possible, then subscribe, guys. Okay, it is like I'm stretching myself too much because I have committed to something, so I have to complete, because even 1% is getting benefit of these questions, so it is okay for me. So bye guys, take care.